and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Shawn Varney.
Hey everybody, welcome to this week's Tech. I'll be talking to you guys on the case study. It's going to be on successful conversion from an HFE-based solvent to a HCFO solvent. So the overview of how the flow chart, how this is going to work with us today. So we're going to go over the customer, the chemistry, soils, parts, materials, the machines that were used, testing, the test results, a conclusion, and then our questions. So our customer is in the medical field. They make knees, hips, joints. They do the screws that go in the joints. They do plates, all kinds of stuff, and much more. They're looking for a suitable replacement for a solvent that's actually being discontinued. Some of the main requirements that we were looking at to help them out with is they need to pass cytotoxicity testing. They needed to pass endotoxicity testing. They needed to have no residues or no staining. They needed to pass some dyeing tests, and obviously must be compatible with their substrates, and no problems there. So the chemistry. It is an old product with them. They used a 3M brand. It's Novec 72DA. You'll see it up here. This is the molecule for that Novec. It was used at 100% concentration. It's a PFAS material, meaning you might hear that called as a forever chemical. It doesn't break down over time. It stays there. And it's an HFE blend. The new chemistry is the KYZEN SLV 901, and you'll see an HCFO blend right here. It is not a PFAS material, so you don't need to worry about that, but it's also used at 100% concentration since it's a solvent. The soils. So this is a combination of oils and coolants that they were trying to clean off. It's used throughout different stages in production as they go through their parts. And why this is important is the soils affect bath life and the effective cleanliness of it. So you'll see on these two charts I put up here, I just did them simply in Fahrenheit and also in Celsius, depending on your preference. They used a Vascomil, they used Unisig, and Swiss cut. You'll see that in a raw solvent of the SLV 901, the boiling point is 118. You'll see as we went through here, we wanted to load the bath for bath life and understand how it changed at 5%, 10%, and 15% soil loading. And you'll see that the boiling points did change as they go up. And that's important as it might show indication of your bath loading and whatnot. The parts. So parts, they were made out of many shapes, all different kinds of sizes for different body parts, right? So they could be as small as a little 1/4-inch screw, all the way as large as possible 10-inch leg plates. So obviously people have different body sizes parts. As a 5-foot person might have a different leg size than a 7-foot tall person. So those leg plates are in nature can change in size. Also, important note to put on that is that they could be a solid block or multiple small parts put together, meaning that they could be all CNC'd from one big plate, one big part, or they could be like a knee where it rolls in a joint and that's two different parts. So they're very complex in nature, meaning that they have blind holes. That's a hole without, just goes in and has no exit. It's just one way in, one way out. Through holes would be like a hole that goes all the way through. You can rinse from both sides. They could have twists and turns. They could be smooth or textured in nature. The reason why they'd be smooth is like a joint, how it rolls, or textured, you actually want tissue and cartilage to grow to it. The materials. So there's several different styles. They had titanium, kind of like you use on a wedding ring or whatnot. You had stainless steel that they used. That's most commonly in the household utensils, right? The fixtures that they were using is polypropylene. They used maybe they're heat treated together or they're held together by stainless steel screws, or some of the fixturing could have been aluminum too as well. The machines. So there was a Crest Solvent S1 vapor degreaser that we used in our lab. You'll see it's an open top style vapor degreaser. These are some of the parameters that we used. We used agitation with ultrasonics. We dipped it in the boil sump, we dipped it in the rinse sump, and then do a final rinse in the freeboard and vapor zones. It was also attached to a KYZEN capture unit. You'll see the before and after. All this simply does is that it is a still that cleans up the solvent. So that used in conjunction with each other ensured that we were removing oils and whatnot out of the machine to make sure that we had the cleanest chemistry possible. The testing. So testing, for the purposes of the privacy and IP intellectual property, we're just going to be showing test coupons and no real parts, but you can follow me and use your imagination here. So you'll see on the top left that this is almost a knee. Pull this off the internet, you'll see it's very simple, has a very smooth texture finish to it, some cartilage and another part on the other side. Those are some examples of some medical parts. On the right hand side here, you'll see an x-ray with a plate, a good example of through holes, and there's some screws holding it together. Very easy. That's kind of just a few parts that they make. But when we went into testing, we obviously wore gloves, we wore masks, we try and keep the particle count as much as possible, any kind of contamination. We used clean bags to send off to a third-party testing. That way it was unbiased. And you'll look on the right-hand side here, it is the before pictures. Now these are test coupons for picture purposes, but we did the same exact thing with the parts. We would submerge them in the fluid. This is oils or coolants. And then we would take them to the wash in the vapor degreaser and wash them. The results after that wash would come back and we would do some physical testing in-house, and some of the parts would go out to third-party testing. So that was that cytotoxicity and endotoxicity I was talking about, and along with other reports. There was a lot of them. So the test results, really passing testing with 72 dynes. You'll see there's a pen marker there on these test coupons for the oils or coolants on this side. On your right-hand side, obviously no staining, no residues or compatibility concerns whatsoever after the cleaning as well. So really in conclusion here, we were successfully cleaning all their parts. We passed all third-party testing that was sent off when it came back clean, no residues left over. We launched on site and did a full-scale production. KYZEN is their main vendor for cleaning chemistry now. And one of the main reasons why is the customer loved the support that we gave and the details that KYZEN would provide for them to make it easier for their transition. They're looking to expand worldwide operations to master testing and results that we performed at the HQ site. So hopefully this will launch globally. It's already in some other sites, which is great news. Some frequently asked questions on the topic. So question 1, are there more concerns other than PFAS for EH&S? We talked about PFAS as a forever chemical, but that's not the only concern that EH&S might have, right? So there's PEL limits, that's personal exposure limits. That's what might be getting outside the vapor degreaser, past that freeboard zone, and getting exposed to the customer. But we have a sniffer that we go around and make sure everything, the temperatures are right, and we're taking parts in and out just fine, so we don't affect that PEL limit. Another question for that might be drain and disposal. So that it is a solvent, some people tend to send it off after hazmat. It typically does not go to drain, or some people use an evaporator in-house and take care of it that way. And flammability, it's non-flammable. That's the good thing about this product. Question 2, will KYZEN assist in converting a vapor degreaser to a new solvent? Absolutely. So we would help you do testing like you saw today. We would also help you do any kind of change out of draining and flushing of the system that you need. Will be on site, and also change out any temperatures, settings and whatnot. Make sure you're set up properly for the SOV 901 to run the greatest that it will. Question 3, how can I check if a material I use contains PFAS or other harmful materials? Well, Section 3 of the SDS lists certain types of chemicals as CAS numbers, which you can look up online. However, the best way is just to contact your supplier of that chemical and ask them if it's a PFAS. So with that, that's what I have for you today. I'll turn you back over to William. Thank you.
Thanks, Shawn. And thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech2tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.